Okay, so I'm going to do this question. It's got this is at your blackboard, one that you actually did. Has a coil and a 101 microfarad capacitor across or hooked in onto a 120 volt 60 hertz supply. The coil has a resistance of 48 ohms and an inductive reactance of 83, and the capacitor is at 101 microfarads. So in series, we have our impedance section, our voltage section, and our power section. If it's asking for the resistive volt drop, we're probably only going to have to deal with these top two because they've given us ohmic values and they want volt drops. So I'm going to have my coil section, and I'm going to be adding that to my capacitor, and then I'm going to have a total. So my coil is going to be a triangle because it's got both components. So I'm going to put 48 ohms here, and I'm going to put 83 ohms here. My capacitor is just a reactive component, so I'm going to have to get that microfarad into an XC. So I take my XC formula here is equal to 1 over 2 pi times the frequency, which is 60, times a microfarad, which is 101, times 10 to the negative 6. And my XC is going to be equal to 1 divided by 2 times pi times 60 times 101 exponent negative 6. And I get an XC of 26.263 ohms. So that goes here, 26.263. And then I'm going to have my total. So it wants the resistive volt drop. So this is the resistance of the coil. So when I draw my voltage triangle, so I'm just going to scratch that out because we don't have to talk about power right now. All I need to do is I got to find current, and then I can multiply this value times the current, and I'll have my resistive volt drop. If it asks for the reactive volt drop, I would times this by current. If it asks for the total volt drop of the coil, I would times this value by current. So we need to find current. So we got to find the total impedance of the circuit because they didn't give us the current. So I have to find the total impedance first, and then I'm going to be able to find my current. So we have to total up these values in the impedance section to find out what the total Z is here in order to find current. So I take the 48 ohms and I add it to any other resistive component, which we don't have because the capacitor doesn't have that, so I can bring that rate straight across to the total circuit values. So I got 48 ohms over here. Now, again, when we think about the phasor diagram, the coil XL, okay, usually we're talking about volt drops if we're talking phasor diagram, but it works in the impedance section as well, as these guys just end up canceling each other out. Okay, so if I go 83 minus 26.263, I get 56.737. Now, because this number is larger than this one, it tells me that when I do find my current, my I is going to be a lag, okay, because the inductive portion is higher than the capacitive portion. So then I want to find my total circuit impedance, so I go 56.737 squared plus 48 squared, and then take the root of that, and I get a total impedance of 74.317 ohms. Okay, now that's where I'm going to be able to find my current because there's a voltage triangle down here as well, and my total circuit voltage is 120 volts. So whenever you get something on the same side of a triangle that's in the same section, so the total section or the capacitor or the coil, current exists between those values. So current exists between this 120 and this 74.317. So to find current, I'm just going to use my Ohm's law. I'm going to take 120 volts divided by 74.317, and I will get my current. So 120 divided by, and I get 1.614 amps. And again, that is a lag because this is due to XL right here because it was larger than the XC. So now that I have my current, I can kind of find anything I need to. I could multiply this by current to get the volt drop across the capacitor. I could find the volt drop across the reactive portion of the coil by timesing this, but they want to know what's the resistive volt drop. Okay, so I'm going to take 48 times that current. So 48 times 1.615, and my volt drop here is 77.52 volts. So that should be the answer to the question. So yeah, I'll grab another one to do. I'll load this one up. Hopefully that helps. This was just it doesn't have a resistive component separate, but it has a coil and a cap. Okay, so this would technically be just an LC series circuit, but hopefully that helps, and I'll post another one here in a sec.